Hello everyone, welcome to Electronics Prepper, the channel where we try to learn as much as possible about electronics to become more self-reliant with technology and prepare for the future. Today we're going to talk about a problem that appears sometimes when we try to make precise measurements or when we try to measure small values in circuits with high impedance. A problem that appears mostly, if not entirely, due to various electromagnetic interference in our workbench or around our workbench. The solution that I propose, and that it's not it's not new at all, and it's not my invention, but it's a very cheap one that anyone can get, no matter where you live, is, well, building yourself a small Faraday cage. I'm making this video in case somebody lands on my YouTube channel on this video and hasn't seen this on other channels or hasn't been explained this by someone else. So the idea is very simple, and let me just go to the workbench in order to just show you the problem and therefore the solution. So the idea is that when we are having a measurement to take in a field that is full of various electromagnetic interferences, we will want to do something to shield that circuit or that thing which we are measuring it as much as possible. If you take a look at this oscilloscope, and I'm going to make a picture-in-picture for you to see better what I have here. On this big camera, you have, on the camera, in the background of the screen, you have the oscilloscope showing you a waveform. On the smaller screen here in my right area, in my right corner, you have the oscilloscope probe. As you can see here at the edge of the screen, there's just one cable, one probe, which is this one, not being connected to anything, and the other inputs are really not connected to anything either. I have one more cable here which is connected to the ground, but I'll explain that in a moment. And yet we see that we, strangely enough, have a 50 Hertz sinusoidal, or, well, it's a signal that appears to be somewhat sinusoidal but not quite. It's deformed, it's got various other frequencies in it, but overall the predominant frequency is 50 Hertz, which is the power line frequency, at least here where I live. And the reason why we see this with the oscilloscope probe not connected to anything is because, of course, we have various electromagnetic fields around here that radiate from the equipments around and are able to be picked up by this portion of the oscilloscope probe. If you take a look at the screen while I'm holding the probe, you will see that the signal is not really changing when I'm touching the rest of the cable up until this point, where the ground of the cable is separated from the middle pin of this cable. But if I touch the probe here, the signal gets stronger, gets bigger, and that's because really this is the only place where these interferences can go into the probe, down the cable, and be picked by the oscilloscope, which is a digital one with pretty high impedance. It's the standard 1 mega ohm impedance, but still it's high enough so that it can pick up voltages produced through basically electromagnetic induction. Now the problem is sometimes we want to measure something that either has a very small value or is influenced by these electromagnetic fields, because it has it's something that we want to measure in a very high impedance circuit. So that's a bit of a problem, because we cannot just well, I kept showing you this in the box, but really it doesn't matter. This phenomenon happens in the air. The problem can be solved through a very cheap metal box. This is butter biscuit metal box that I found. Well, you can find it pretty much in any supermarket or hypermarket extremely cheaply. This cost me less than the equivalent of €3 or $3, depending on how you want to see it. Maybe I should put it full screen so that you can see it better. It came with the biscuits inside, which is nice because you can eat them, but then you can use the box itself. It's an aluminum box, as far as I could tell, and it's perfect to make a Faraday cage so that you can perform measurements by putting your circuits inside and basically having them shielded from external influences. There are three things that I've seen are necessary, were necessary for me to do in order to actually be able to use this box. The first thing is to use some sandpaper to sand the rim of this box, because for some reason they coated this margin with I don't know, I think something plastic, and it just didn't made any electrical connection. So if I would take a multimeter, put it on continuity test and place the two wires pretty much anywhere around the rim, around the margin of the box, they would not beep. It would not make any electrical contact. We want for this box to be to make electrical contact with the lid, which I'll show you a bit later. Well, it's a standard lid, but anyway. So the first thing that you want to do is to sand this this rim so that you remove that piece of plastic shit and just expose the aluminium so that it will make electrical contact with the lid. The second thing that you want to do is to basically cut a small hole on the outside somewhere, it doesn't really matter where, enough so that you can put as many cables as you think you would need, and at the same time so that the lid can still close, which will kind of go over a small portion of this area. The third thing that you will also need to do is to electrically isolate the interior of the box, because the last thing that you want this box to do is short circuit the things that you're going to put here, your circuits, your cables, your whatever. So I don't know, use whatever you want to isolate the box itself. I used a piece of plastic that I had from my 3D printer. I just cut it in a round shape and put it at the bottom, and then on the side, on the circular side, I used some duct tape or something like that, and that's just fine. You might find it necessary, so far I didn't have to, but I'll probably do it at some point, to basically isolate the bottom of the lid as well, so that when you put things here and close the lid itself doesn't make short circuit to the things that you're putting inside. So that's pretty much it. You need to do these three small things and the box is perfect for you to start using it. And now let me demonstrate why you might need this. I'm not gonna use something, I'm not gonna try to actually measure something. All I'm going to try to do is to eliminate this thing that you see on the oscilloscope because we don't want that, because again, the oscilloscope, since it's not connected to anything, should not be able to see anything. I'm not saying that it's not normal for it to see some waveform, again, due to induction and electromagnetic interference. It's normal for it to do it, for it to do so. However, when we are connecting it to something, we don't want this to be strong enough to affect our measurements. So we use this box, right? And you can take a look at the bottom right corner. I'm just placing, to show you how it works, I'm just placing the probe here. Again, I'm not connecting the wires to anything at all. And I'm going to close the lid, and of course nothing will happen yet. But if I connect this box to the ground, I will basically eliminate this noise. And the thing is, if you take a look at the image behind, pretty much every oscilloscope has one of these connectors on the front panel where you basically can connect and you should connect when you buy the oscilloscope or a new probe. You should connect the probes and make that fine adjustment, that calibration or probe compensation, however it is called. One of those connectors is also for the ground, which is great because we can just clip a crocodile cable, and which I did. And so now if we connect this ground to the box, the metal box, bang, the signal has completely disappeared. Why? Because now the radiations are being picked up by this metal can, and because the metal can itself has a very low impedance with the ground of the oscilloscope, there's pretty much nothing left for the middle wire of the cable, so the oscilloscope doesn't see any more signals, which is great. So basically now with this lead being connected to the ground, we can connect our probes to whatever we want, and when we close the lid, we only get to see what we want to see, whatever we are measuring from our circuit, right? Again, it's extremely important to ground the box for this effect to happen, because if you do not ground it, the box itself will be able to radiate the electromagnetic interference inside, and well, it will get to the oscilloscope probe. So that's about it. There's nothing fancy, nothing super complicated, but you know, certain people don't know about this, and I've been doing electronics for 2 years now as a hobby, but I've been pretty active in electronics for the last 2 years, and so far I did not need it to use this, but now I'm trying to study noise, and I'm trying to measure the noise of various circuits and some components. So now I've had this need for such a box, so I'm thinking, yeah, maybe there are others like me as well that will appreciate this video. Maybe there are some of you who don't know about this trick. So now you know. A cheap metal can from a metal box from butter biscuits will do just fine. So I hope this was useful for you as well. Thank you very much for watching. Don't forget, those of you who want and can support me financially, I have a Patreon page. The easier it will be for me to study, the more I will come back to you and I will show you more things, and I will teach you various things, how to build, maybe even how to fix, if it will be possible. All the help will be much appreciated. So thank you very much for watching, and I'll see you in the next video. See ya!